Hello, grade 11C, welcome back. In last recorded session, we talked about the atom and the atomic structure, and we know the atom consists of three particles: protons, neutrons, and electrons. Protons and neutrons found inside the nucleus of the atom, while electrons revolve inside the energy levels around the nucleus. So, in ordinary states, the number of positive proton must be equal the number of negative electron, okay? So, the atom is electrically neutral. But during chemical reaction, atom try to gain or lose or share to complete outermost energy level and form stable compound or stable element. So, the number of electrons lost, or the number of electrons gained, or the number of electrons even shared by atom, called the valency of atom. Okay, so when the atom lose or gain, it changes into ions. But what's meant by ion? We have two types of ion: positive ion and negative ions. Positive ions, it's the atom of metal which lose electron or more during chemical reaction. So the number of positive proton become more than the number of negative electron after the atom losing electron or more. Okay, so in this case, the metal atom change into metal positive ion, which carry number of positive charges equal the number of lost electron. Look at the example in front of you. Aluminium carry three positive aluminium ion carry the three positive charge. Okay, so the atomic number of aluminium equal 13, while the mass number of aluminium atom equal 27. Again, the atomic number of aluminium atom equal 13. Okay, that's mean the number of electron and the proton equal 13. Okay, in ordinary state, the mass number of aluminium equal 27. When aluminium atom during chemical reaction lose 3 electron, it change into aluminium positive ion. Aluminium positive ion carry 3 positive charge. That's referred to the aluminium atom lose 3 electrons. So the number of positive proton equal 13, while the number of negative electron become equal 10. Okay, so the positive proton more than the negative electron in aluminium ion. So we say that this is an aluminium positive ion, and the number of neutrons doesn't change. Number of neutron calculated by mass number minus atomic number, which equal 14. Again, atomic number, the number of protons equal 13, while mass number equal 27. The proton number equal 13, which equal the atomic number, while the number of electron change after aluminium atom lose 3 electron. The electron number become 10. Okay, because aluminium atom loses 3 electron. Neutron number equal mass number 27 minus atomic number, which equal 14. Okay. Another example. This is example is for positive ion. We have another example for negative ion. Look at the nitrogen. In case of nitrogen, the mass number equal 14, the atomic number equal 7. But nitrogen carry 3 negative charge. Okay. Atomic number equal the number of proton equal 7. Mass number equal 14. Number of proton equal the atomic number equal 7. While electrons stop and focus with me. Nitrogen atom. In ordinary state, the number of positive proton equal the number of negative electron equal 7. But during chemical reaction, nitrogen try to gain electrons to complete outermost energy level. Okay? So after gaining, the number of proton become less than the number of electron. Okay? So the nitrogen atom change into nitrogen negative ions, which carry negative charge equal to the number of gained electron. Nitrogen gain 3 electrons, so it carry 3 negative charge. So the number of electron after gaining become 7 plus 3 equal 10. Neutrons, number of neutrons, okay, mass number minus atomic number, 14 minus 7 equal 7. Isotopes. What's meant by isotopes? Isotopes means the atoms for the same element, okay, have a same number of proton but differ in the number of neutrons, okay. Again, we have example for isotopes. Hydrogen has three form of isotopes, okay. Look at the example of hydrogen. Hydrogen, mass number equal 1 and atomic number equal 1, okay. This hydrogen has no neutron, okay, and hydrogen element, the only element which has the mass number equal the atomic number, okay, due to the absence of neutron, there is no neutron inside its nucleus. So hydrogen atom considered a very light atom, okay, or the lightest atom in periodic table. Hydrogen, in this case, okay, this isotope of hydrogen. Hydrogen, in this case, its mass number equal 2, while atomic number equal 1, okay. So hydrogen has 1 proton, has 1 electron, and has 1 neutron. And in this case, we named hydrogen with deuterium. The second isotope, in this case, mass number equal 3, atomic number equal 1, okay. So in this case, hydrogen has 1 proton, 1 electron, and 2 neutrons. And in this case, we named hydrogen tritium, okay. Again, what's meant by isotopes? Isotopes means atoms of the same element. We have different atoms with the same element, the hydrogen element, okay. The common between them, or they have the same number of protons, but differ in mass number. In this case, 1, in mass number equal 1. In this case, mass number equal 2. In this case, the mass number equal 3, okay. So the difference between them in mass number due to the difference of number of neutrons, okay. In this case, no neutron. In this case, 1 neutron only, and in this case, 2 neutrons. So, in case of hydrogen, in number of proton equal 1, in number of electron equal 1, while in number of neutron equal 0, okay. While In deuterium, a number of proton equal 1, okay? Number of electron equal 1, while number of neutron change and it has 1 neutron, okay? In tritium, in this isotope, number of proton equal 1 also, okay? Number of electron 1, while in number of neutron change and become 2 neutrons, okay? So we note that the difference in number of neutron which affect to the number of mass or the mass number of the atom, so the change in the mass number due to the difference in number of neutrons inside the nucleus between isotopes. We must know also the distribution of electrons inside energy levels. Each energy level is saturated with the definite number of electrons, okay? And we applied rule 2n power 2, okay, to know the number of a definite electron which occupied by, which distributed inside the first 4 energy levels. So, by applying 2n power 2, which n equal the number of energy level, okay, we found that K saturated with 2 electrons, L saturated with 8 electrons, M saturated with 18 electrons, N level saturated with 32 electrons, okay? Fine. We applied, okay, magnesium. Magnesium atom has the atomic number of magnesium ion equal 12. So it has 12 electron. Okay? We must distribute the 12 electrons inside energy levels. So K saturated with 2. So the remaining 10. L saturated with 8. So the remaining electron 2. So M carry 2 electron. Okay? M level, okay, not completely filled with electron. So magnesium atom, okay, active atom, which can share in chemical reaction to, okay, lose 2 electron and change into a stable ion or positive ion. Chlorine, we must distribute 17 electron, okay. K carry 2 electron from 17. L carry 8 electron from 17, so the remaining electrons equal 7, so M carry 7 electron, okay? The outermost energy level, M level, not saturated with electron, so chlorine atom, active non-metal, which can share in chemical reaction to complete outermost level. Calcium have 20 electrons, okay? K level carry 2 electron, L level carry 8 electron, M level carry 8 electron, and N level carry 2 electron, okay? Vanadium, and so on, okay? We can determine the type of element from outermost energy level, okay? As when we see we look the outermost energy level, and from the number of electrons inside the outermost level, we can determine the type of element. We have three types of element: metals, non-metals, and inert gas, okay? Metals They are elements which have in outermost energy level less than 4 electrons. So the outermost level may contain 1 electron or 2 electrons or 3 electrons. Okay? Like magnesium. Magnesium contain in outermost level 2 electrons. So it's called metal. Okay? While non-metal, they are elements which have in outermost energy level more than 4 electrons. Maybe 5 electrons, maybe 6 electrons, maybe 7 electrons. Okay? So when you see the chlorine, okay, the outermost energy level contains 7 electrons, so we say that chlorine atom is non-metal atom. Okay? So metal element which have 1 or 2 or 3 electrons in outermost energy level, while in non-metals have 5 or 6 or 7 electrons in outermost level. Okay, and the inert gas or a noble gas like helium, argon, krypton, xenon, neon, okay, their outermost level completely filled with electron, which have 8 electrons in outer level. Okay, so they don't take part in chemical reaction. Thank you. Grade 11.